So this is the second period video. First period video is posted elsewhere. You can find it for those problems. So this video will be 2, 5, 8, 11, and 14. If I remember right, 2, 5, and 8 are multiple choice. 11 and 14 are free response. Okay, number 2. The graphs of the function g and the line y equals x are shown in the figure on the right. The graphs intersect at 0, 0, 1, 1, and 2, 2. Which of the following expressions does not give the area enclosed by the graph? Okay, well, before I look at those, my thought is I'm going to have to do top minus bottom from 0 to 1, and then a different top minus bottom from 1 to 2. So that's the one I'm thinking is right. So 0 to 1, 1 to 2, g and x. So g minus x, x minus g. So C is definitely right. That's how my brain would do that first. Okay, now we got some of these absolute value things going on here. From 0 to 2 of x, the absolute value of x minus g. So that absolute value means this would always be positive, so it wouldn't matter which one we did first. I mean, it wouldn't matter which one came first, top minus bottom or bottom minus top. So this one would also work. We did not talk about doing it that way. Because if you get a no calculator, if it shows up on a no calculator part of the test, you're not going to do it that way. You can't do it that way. But if it shows up on a calculator part of the test, you could do it this way and let your calculator do the absolute value thing. So A works. C is sort of our preferred way. B puts the absolute value bars outside of everything. D splits them up and then takes the absolute value. Okay, let's see here. 0 to 1 of x minus g. That's backwards, so that's going to be a negative value. 1 to 2, but this is also backwards, so that's going to be a negative value. So we add up the two negative values, and then we make them positive. That means D would work. Like, you should not use D's method, because that's really confusing, but D would work. C does the whole integral, so that means x minus g, that means this would be positive and this would be negative. They add those together and then take the absolute value. That's not going to give you that area. So B would not work. So in my mind, A is, maybe you use A if you have a calculator. If you don't have a calculator, you'd use C. And D would just be if you're trying to be confusing. But it would still work, because they switched both of the orders, but then took the absolute value at the end to make it positive. Number 5. Oh, missing area. The shaded region in the figure below is bounded by the graph of square root of cosine. I'm going to call that y1. That's got to be that, because that's the only curved thing in there. X equals 7, x equals negative 7, and y equals 2. What is the area of this region? I'm just thinking it's the rectangle minus the cosine thing. So it's the rectangle minus negative, whoops, I shouldn't go negative 7 to 7. I need to figure out where those are. So, I don't know, of y1 dx. The rectangle's easy because that's 14 by 2. So it's 28 minus something. And just looking at my answer choices, I'm pretty sure it's not A or B. My guess is A or B. One of those is probably the area under the cosine thing. Okay, let's figure out what my interval needs to be, because I don't know what those limits are. And this is why you have a little more time on the calculator section than the no calculator section to do stuff like this. Well, I guess I should graph it from -7 to 7. That would definitely let me see everything. Alright, it looks like it doesn't connect. This is similar to what happened on the hot tamale graph that you guys drew, where it didn't quite connect. You weren't sure what was going on. It's just the calculator just connects the dots. And if it doesn't get a dot, then it doesn't connect them. So it looks like it doesn't go all the way down. Let's see if we can figure it out, though. I want a 0. Ooh, but I don't think I'm going to have a left bound and a right bound, because it doesn't go below the axis.
Intersection?
I would have to intersect it with y equals 0. So let's do intersection, but I'll have to throw in a y equals 0 to give it something to intersect. Second calc. Intersect. First curve, second curve. And my guess will just be over here somewhere. Bad guess. I don't think I've ever gotten that error before. Bad guess. Let's try that again. I wonder if I went too far to the left. Second calc, intersect. First curve. Oops. First curve, second curve. I think I need to make sure I'm not out of bounds there, that graph still exists. So I'm not going to go so far to the left this time. No sign change. No sign change. It's looking for where it changes from positive to negative, but the square root's always positive. That's why I'm not getting a sign change. Thoughts? Gonna have to go. What I really want to know is, where is the square root of cosine of pi x over 10 equal to 0? So what's that? The table only works if we get lucky to hit it. So I mean, we can look and see. Maybe it works. Graph, table. So I want to know where. Oh, look at that. Table worked. It hit it at 5. And I assume -5. I guess I should go check to make sure. So we'll go -5 to 5. Good call on the table. I was going to go kind of algebra my way and square both sides. And actually that one you could do and find its intersections. But good call on the table. -5 to 5. y1 dx. Right, now I'm ready to type it in. Let's see, 28 minus math 9, -5 to 5, y1 dx. 28. That's the big rectangle, minus the area under the cosine graph from -5 to 5. Takes a little bit of thought to do all that math. Goodness, takes a lot of thought to do all that math, apparently. 20.372, well, our answer's there, so I feel pretty good about that. By the way, that 7.628, that was the area under the... Right, that was a yucky one because of finding those limits. I guess if worst comes to worst, you might have just looked and guessed 5 and hoped that you got an answer.
Well, it looks like it was 5, so...
Or, yeah, like it looks like it's 5, so let's go to the table and confirm that it's 5. That's definitely better than just hoping it's 5. 258. What is the area of the region bounded by the graphs of y equals sine of x and y equals negative sine of x from 0 to 4 pi. Okay, sine of x. Again, you've got a calculator, but hopefully you can do this without a calculator, at least some of it. Sine of x looks like that, but to 4 pi means I'll do it again. Negative sine of x would be the flip of that. Okay, so I don't think I want to do, I definitely don't want to do 0 to 4 pi as an integral. Because if I do 0 to 4 pi of y1 minus y2, do you know what my answer for that's going to be? It's actually one of the answer choices, because I bet there's some people that would do this. If I do y1 minus y2, where this one is y1, and the other one's y2, because the top and bottom are switching, if I just type that into my calculator, this area is positive, that would be negative, that would be positive, that would be negative, I'd get 0. Now hopefully you wouldn't pick 0, because well, clearly there's area between there. So if you type that in and got 0, hopefully you'd realize, wait a minute, something's not right. So I guess the official way would be go to do 0 to pi, pi to 2 pi, 2 pi to 3 pi, but that's a lot of work. What's the shortcut here? No, you don't know the shortcut, you just realize that that's a lot of work.
Do 1 times 4.
Yeah, find one of them, and I mean, my picture notwithstanding, I'm pretty sure those areas are all equal to each other. So let's do 4 times 0 to pi, y1 minus y2. I'd better be careful because I don't have those in y1 and y2 yet. So if I type that in, I'm going to get an answer that doesn't make any sense. Sine of x, negative sine of x, which reminds me, always be in radians for calculus. So 4, math 9, 0 to pi, y1 minus y2 dx. Yeah, because y1 minus y2 to 0 to pi, that's this area, and then we want 4 of those. 16. It says 8. Let's see. Sine of x and negative sine of x. I graphed them right on the interval 0 to 4 pi. So there's 0 to 2 pi. That's what that looks like. 0 to pi, top minus bottom. I'm liking my answer. Sine of x, negative sine of x. I graphed those, remind myself that I graphed it correctly. If I wanted to try to check that using a different method, I could do 8 of those. 1, 2, 3, 4, 5, 6, 7, 8. That should be the same thing. 8, math 9, 0 to pi. And now I'm just doing y1. And I'll sort of double it with the 8 thing. Also 16, so I'm sticking with 16. Because each one of those is 4, and each little half piece is 2. Sticking with 16. 8 and then 11. Okay, now we hit a free response question. Let's see, there's 2 free response questions left, and we have 30 minutes left, so that should be perfect. Free response questions are supposed to take 15 minutes. They usually take me a little longer when I'm doing them up here because I'm slowing down and explaining and showing and checking calculators and that sort of stuff. So we'll see. Let's see. We started this one. The video's at 15:26, so we'll see if I can finish this before we get to 30. Let R be the region enclosed by the graph. This one's no calculator. Enclosed by the graph of g of x equals -2 plus 3 cosine whatever, and h of x is this parabola. The y-axis, the line x equals 2. Find the area of R. Okay, first thing I think I would do is identify who's who. That's G, that's H, just because I know what a upside down parabola looks like, and this looks like a cosine graph. So the area of R would be top minus bottom from 0 to 2. Top minus bottom from 0 to 2. Top is h of x, bottom is g of x, and if this was a calculator question, I'd be ready to go type them into the calculator. I might have had y1 and y2, but no calculator means I got to do this by hand. So h of x is 6 minus 2 times... I'm going to square that out because I don't want to take an antiderivative of the thing squared. I think it would be easier if I antiderivative x squared minus 2x plus 1. Minus -2 plus 3 cosine pi over 2x. So this is just an annoying problem to test if I can take the antiderivative of some power rule things and a cosine thing. Let's clean it up first. 6 minus 2x squared plus 4x minus 2 plus 2 minus 3 cosine pi over 2x dx. I'm still doing algebra right now. The minus 2 plus 2 goes away. I guess I got that going for me. But that's about it. Now it's time to take the antiderivative of all these pieces. 6x minus 2x cubed over 3. X squared divided by 2, I get 2x squared. And then I'm going to need to be real careful on this one. Antiderivative of cosine is sine, so it'll stay negative. Argument stays the same. But that inside stuff there, that pi over 2, if I took a derivative of this, I'd be multiplying by pi over 2. Like that's the chain rule. So if I was working backwards, there'd be a pi over 2 on that, which means I need a 2 over pi to sort of undo the chain rule. My guess is that's probably the most missed part of that problem, is undoing that chain rule piece. And then from 0 to 2. A safe stop in our very near future here. 6 times 2. I'm plugging in 2. And I'm not even going to evaluate because I don't want to mess up something dumb here. 3 times 2 over pi. Like I'm really not evaluating anything. I'm just plugging things in. So that's plug in the top. Minus plug in the bottom. If I plug in 0, I need to be careful. Like all of those are definitely 0. What about the sine of 0? What's the sine of 0? Sine of 0 is 0. So I'm okay. I can just put minus 0. Or I can plug it all in, because leaving sine stuff is a safe stop. But I'm just going to kind of recognize that all the rest of that is 0 and stop there. So that was a pain, but you're going to get one that's kind of a pain on the free response that makes sure you can take an antiderivative by hand. Region R is the base of a solid. For the solid at each cross-section perpendicular to the x-axis, dx, has an area, for the solid at each x, the cross-section has an area of 1 over x plus 3. Find the volume of the solid. Okay, so I'm going from 0 to 2, and I'm thinking area, each cross-section, but it just tells me the area. So I'm not worried about like top minus bottom squared or root 3 over 4 squared. Like, it's just flat out telling me that the area is 1 over x plus 3. So in some sense it's easier than all the other ones we've done. I didn't have to know a formula. The area is 1 over x plus 3. Oh, now I know why they did this. What's the antiderivative of 1 over x plus 3? Oh, I saw a few of you mouth it. What's the antiderivative of 1 over x plus 3? Natural log of x plus 3. 0 to 2. So that would be natural log of 5 minus natural log of 3. Which is the natural log of 5/3, but why would we do that? Like, just leave it alone. So B was tricky in an easy sense. Like, I was worried about the volume with all those weird formulas, but it just told me what the area is. Part C, write but do not evaluate. An integral expression that gives the volume of the solid when R is generated, or solid generated when R is rotated about the horizontal line y equals 6. 1, 2, 3, 4, 5, 6. Okay, so going this way, so that means it's dx. So 0 to 2 of dx. Disk or washer? Washer, because there's space between the axis and the region. So I just need a little r and a big R now. Okay, big R is top minus bottom. Let me slow down here. Big R squared minus little r squared for a washer. Big R is top minus bottom. So look at my picture. The top is this line, 6. And the bottom is g of x. 6 minus g of x. Little r, top minus bottom. 6 minus h of x. So pi 0 to 2, 6 minus g of x squared minus 6 minus h of x squared dx. And if you had called those y1 and y2, that would be fine as long as you identified clearly which one was y1 and y2. Write but do not evaluate an integral expression that gives the volume. Okay, I think that's all it wanted. So that's one where part C might have been the easiest of the bunch for some of you. So when you're doing these multiple choice questions or these free response questions, they don't always build on each other. So if you get stuck on A and you're like, man, I get lost in all that antiderivative stuff, keep going, because B really didn't have much to do with A and C didn't have much to do with either one. I'm going to guess, like, those were sort of all equally difficult, so I'm going to guess the points were distributed 3, 3, and 3. So, I mean, let's just take an average student. Hopefully they get this far on part A. And that's probably worth one of the 3 points. Maybe B was too confusing and they don't get any, so this is going to be a below average student here. Maybe B is too confusing and I don't understand. Leave it alone. Don't get anything. But C, it's like we've done a bunch of those. Hopefully you get all 3 of those points. And so if you got the 3 points there, and maybe you eked out a point or 2 from part A, so 4 out of 9, that's 44%. That's headed for a 3. 5 out of 9, that's 55%. That's headed for a 4. So again, as you're doing these, fight for every point, but realize you don't have to get close to all the points to make a 3 or 4 or even a 5. So as you're going through that on May 13th, don't panic when you hit especially a piece of a problem and you're like, I don't know. I don't understand what's going on with that. No big deal. No big deal. Get the straightforward ones and get a 3. Get a few extra points somewhere along the way, get a 4. Figure out a few of the tricky ones and get a 5. Like, not even all the tricky ones, just a few of the tricky ones. Let's see. So that one took me 11 minutes. But I don't know. The time wasn't an issue for that one, I would say. 7 and 14. This one we get to use our calculator. Thank goodness. Another old AP test question here. Let R be the region in the first quadrant bounded by the x-axis. Okay, yep. Well, if it's in the first quadrant, I don't know that they needed to say bounded by the x-axis, but just to be clear. And the graph of natural log x and 5 minus x. And I can put it in my calculator, and I probably will, but I can also just tell by looking which one is which, because one of them is a line and one of them is not a line, so I know who's who here. Okay, so that's the region R. Part A, find the area of R. Ooh, do you want to do this as a dx or a dy problem? If you go dx, I'm okay with that. There's something you have to think about if you go dx. So Sarah, if you want to go dx, I'm fine. What are you going to have to be careful about? I'm going to do it both ways. So if you go dx, you're thinking top minus bottom, but that changes right there. So I need to figure out where there is. I'll call that A and B. I don't know that that's 1. That looks to be a little bit higher than 1. So if I'm doing dx, I've got to go 0 to A of, I'm going to call this one y1 and this one y2. y1 minus y2 dx plus A to whatever that is. I've already used B, so I'll call it C. Wait, not y1 minus y2, just y1. And then A to C of y2. If I go dy, then I'm going right minus left. Let's see, I have to go 0 to B. And, so I have to switch this around. If that's 5 minus x, and I need it in terms of y, then what does x equal? Let's see, move things around. 5 minus y, that would be the rightmost piece, minus the leftmost piece. Y equals natural log x. And if I flip that around, x equals e to the y. So, like, in terms of typing things into the calculator, dy is probably easier, but conceptually dx might be easier just because you're used to doing dx. And it's pretty easy to see where it's split up. You just have to make sure you account for both pieces. I'm going to do it dy. I also need to figure out where all those intersections are. I'll probably need it all those places anyway, eventually. So natural log of x and 5 minus x. And it's nice when they give you a graph because then you know what your window needs to be. I'm going to go negative 1 to 1, 2. Oh, this would be 5. I can tell what that is. So negative 1 to 6. And my y value, I'll go negative 1 to 2, and that should be plenty. So there's natural log. Uh-oh. Type something in wrong. Oh, I'll put an extra parenthesis there. Natural log. And then here comes 5 minus x. So c is equal to 5. Let's find that intersection, though. So the x value is 3.69344, and the y value is 1.3065586. So I'm going to store both of those. I'm definitely going to store b because I know I need that. First one's a, and then b was, I don't know how to get, if there's a better way to do this other than typing it in. I'm going to store that one as b. Okay, so now I've got a and b in there. Math 9, 0 to b. 5 minus, I'm going to keep it in y, minus e to the y, dy. Again, if you don't like hitting the y's all the time, you can put it all in x's. 2.986, is that what you got? 2.9.
She got 2.986. I got 1.986. I did my
If I had a lot of extra time, I suppose I could do it the dx way and check it. Math 9, 0 to a, y1, dx, plus math 9, a to 5, whoops, a to 5, not 0 to 5. This is the split it into two pieces way, which, I don't know, is it easier to split it into two pieces or is it easier to do it dy? Hopefully I get the same number here, the same answer. The calculator did not like splitting it into two pieces. Uh-oh.
That's what I have.
That's what you got. Oh, I know my problem. I see my problem. If I want this area, I need to go from 1 to a, not 0 to a.
Leading us astray.
I did lead you astray. Now let's see if we get the same thing. Now we get the same thing. That was also a lot quicker. 2.986. My guess is they would rather you do it dy, but if you get the right answer, it's okay either way. Region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis. Sigh of relief, because what does perpendicular to the x-axis mean? dx is a square. Okay, so squares coming up out of the page here. Write, but do not evaluate, an expression involving one or more integrals that gives the volume of the solid. Or more is a bit of a hint there, because when we think about splitting it up, we're going to have to split it up. We're going to have to go 1 to a to 5 again. So 1 to a, the area of that is just s squared, dx plus a to 5, s squared dx. But s is different for those two different pieces. So 1 to a. If I labeled it y1, I can go with just y1 squared dx. And then a to 5 is y2 squared dx. So because of how that one was set up, I had to do dx, and then I had to split it up into two pieces, which it was maybe gently hinting at with that one or more thing there. Part C. The horizontal line, y equals k, divides R into two regions of equal area. Write but do not solve an equation involving one or more integrals whose solution gives the value of k. We've done this before. So somewhere in there is k that divides that into two pieces. The top piece, the bottom piece have equal area. And now they're forcing me. I've got to do right minus left. I've got to do dy. So I'm going to go from 0 to k equals the area from k to b. I already found out what b is. That alone probably gets you a point on that problem. Right minus left, we did this already, is 5 minus y minus e to the y. And on the top section, it's still the same right minus left. 5 minus y minus e to the y. And I got a lot of numbers in there, but k is what we're solving for, so I don't need k. B, I told them what b is. I found that. So that's all I need to write for that one. Alright, let's assume that was another 3-3-3 problem. You won't know when you're taking it. It doesn't matter, like fight for all your points, but I feel like part 1, you should get those 3 points. Part 2, I don't know. This one I would hope a lot of you get 9 out of 9. And honestly, if you get 1 or 2, you get 6 free response questions. If you can get all 9 points on a couple of them, you're going to be great, because that covers up a whole lot of previous mistakes if you can do that. You could zero a few or zero one of them. And anyway, if you can hit 9 out of 9 on a few of them, you'll be sitting pretty for the AP score.